Hello, my name is Mason Dana, and today I will explain my R code for the Molar solution question. So what we had to do is write functions to calculate the amount of chemicals needed in grams to make a molar solution, and then we were given different compounds. So CuSO4, MgSO4, and CaNO3 too. And for all of these, we were giving the molecular mass, or MM. So the first function that I wrote was just called molar solution number 1. And the function was very simple, just x and y. And I multiplied the molar mass, here it's the molar mass of CuSO4, it could have been anything, times x to the 3 and y to the 3. And this would give us the correct units. So if I save this, and now it's in my environment, this is really simple, but for every single one, I'd have to write the molecular mass. So then I made a second molecular solution, a second function. And so my second function was molar solution 2. And this function contained the concentration, volume, and the molecular mass. So here I multiplied the molecular mass times the concentration times the volume, and all of it divided by 10 to the 6. And this again would give us the correct units. And if I use this, then the only thing I have to input is the concentration I want, the volume I want, and the molecular mass of the compound that I'm using. This is a more useful function because I can use different solutions, I can make different solutions, whereas the first one would only be calculating for 1 mole, essentially, 1 mole solutions. And the third function I created is called molar solution 3. And here I have a function which has the concentration, the volume, and the formula. So here I assigned MM with these values, and those, if you notice, are the same molecular masses that were given in the beginning of the question up here. And then I assigned names to this, and the names correspond to the molecular mass. So CuSO4, the molecular mass is 159.61. Here you can see that, and all of these correspond correctly. And so here, if I wanted to use this function, I could just put in the concentration I want, the volume I want, and then essentially the name of the formula. And it would pull up the molecular mass that corresponds to that. So the actual problem was to use our function to make a solution that was half a liter and 0.1 moles of CuSO4, and then another solution that would be 0.25 liters and 0.5 moles of MgSO4. And so in order to do this, I used molar solution 2 for both of them. And so I want a volume, and remember again that everything is being divided by 10 to the 6. That's why the units might look a little weird. So I want a concentration of 100. So 100 times 10 to the 3. So up here, if you visualize it that way, that will give us 0.1 moles. I want my volume to be 0.5 liters, and so here I wrote 500 because again, if it gets multiplied or divided by 10 to the 3, that'll give me 0.5 liters, and then times the molecular mass of CuSO4. And I did the same thing here with the molars for the second question. So I put a concentration of 500, which will give me the 0.5 moles, a 250, which will give me the 0.25 liters, and then the molecular mass of MgSO4. So if we run these, down here we can see that the molecular mass needed in grams, sorry, the weight needed in grams of CuSO4 to make this solution would be 7.9805, and the grams needed of MgSO4 to make the second solution would be 15.04575. I hope you enjoyed this. I hope it was educational, and have a great day.